Okay. So today, because we will talk about diodes and we will talk about transistors, all these devices are, in these devices, usually we use what? We use semiconductors, okay? And each device, in each device, we control the conductivity of the semiconductor, okay? Sometimes the device is working based on some conductivity of the semiconductors, okay? Okay, so in this chapter, which is an introduction, okay, it's an introduction about the materials, okay? So we will talk about the atom. Did you study the atom at school? No? Basic structure. We will study the basic structure, okay? And we will talk about semiconductors, okay? And doping. Anybody knows what is doping? What? No, not in electronics, okay? Not in electronics. It is important to understand the word. What is it? The idea. What is doping? Okay, doping. Okay. You know, in sport, injection, right? That's true. So we say that this guy, he was doped. Okay, some injection of illegal things, right? They added something to his body to be stronger. Okay, so it is prohibited in sport. So this is the idea of doping. We will see what is doping in semiconductors, okay? And then we will start by diode, describe the diode, and the characteristics of diode, okay? Maybe we will finish some small part today, and we will continue tomorrow, okay? Fine? Is it okay? No problem understanding? Okay, that's cool. Okay, so simply, what is an atom? What is atom? You know the Earth, and we have the moon, right? Right? In this structure, if we compare this structure, the Earth and moon, the Earth is the nucleus, okay? Okay? The center of the atom, okay? The nucleus, it has two things. The first thing, we call it a proton. Proton, it means what? What does it mean, a pro? Huh? What is the opposite of a pro in English? Usually we say pros and cons. Okay? We say with or against. Okay? Pro, it means positive opinion. Okay? Cons means negative opinion. Do you know what does it mean, this one in French? Means stupid. So take care, okay? So yeah, so this one, a pro, means it is, what does it mean? It is positive, okay? Positive items or particles. Neutrons, nu, it means what? Neutral, right? Neutral, not positive, not negative, okay? So these two particles exist where? Inside the nucleus, inside here, inside this one, inside the Earth, okay? And we have the electrons. Electrons are where? Like the moon, okay? The moon is outside Earth, and it circles Earth, right? It has a fixed orbit, right? The moon around the Earth, it has fixed orbit. You know the orbit? You have Earth here and moon. It moves in fixed orbit. Okay? Why? Huh? Who spoke? Satellite? Okay, very good. Very good idea, okay? But why the moon, it has a fixed orbit? Why? What? Because? Perfect. Because of gravity, okay? Gravity, it means what? It means that Earth pushes the moon inside. It holds it, okay? It has some power to hold it inside. Is it fine, ladies? Something funny? If it is, please make us laugh, okay? Okay? Otherwise, you should not, okay? So, there is some power in Earth which makes the moon circle in this orbit, okay? Right? If we have some power stronger than this power, can we let the moon go outside? Be free? Yes, we can do it. But we need a huge power, huge energy. Okay? Fine? That's why in the satellites, it has two kinds of satellites we have. Okay? The first kind of satellites is geostationary. Geostationary, okay? Geo means geographically stationary. Geostationary, it means if we make the satellite over Korea, it will circle the Earth all the time. It will be over Korea. Okay, it means geostationary. It must be at distance, I think 335 kilometers. I'm not sure about this, but it's almost. Okay. So we have some power from Earth to push the satellite in that fixed place, right? But why the satellite does not come to Earth? Because the Earth is pushing it towards it, right? How can we make it in this orbit? How? Huh? It must have some speed, fixed speed, okay, to make it equilibrium, okay, to make the direction in this way. Okay, we have power this one, and we have power of the speed in this one. The summation should be in this orbit, the power, the direction of power. Okay, so it can be fixed. Okay, so we can control that. We can make it until 20 years. After that, we cannot make the satellite go in the same orbit. So we stop using that satellite. Okay? Okay? In the case of, so if we give more power for this one, it can go outside. Right? It can be released from the power of, from the gravity of Earth. Okay? So the same idea, exactly same idea with the nucleus and the electrons. Okay? The electrons are fixed, are attached or circles the nucleus, but if we give energy to the electrons, they can go out, leave the influence of the nucleus. Okay? Fine? Fine? Hey. So it's the same idea. Okay? So we have the electrons and that. So there is some guy, his name is Bohr. This guy, he said that the electrons, they circle the atom, okay, in a fixed orbit, like this one. In this In this study, they call it shell. Shell, okay? We have several shells, okay? Each shell, the electrons have certain energy. For example, in shell number 1, electrons have energy 1. In shell number 2, they have energy 2, and 3 and 4, okay? Different. Okay, so there is something we call it atomic number. The atomic number is the number of protons, right? Okay, the number of protons is fixed or not? Fixed. Fixed. You cannot modify that. Okay. At least in our semiconductor applications, we don't modify that. Okay, that we cannot. But electrons, can we modify the number of electrons? Can we modify the number of electrons? Yeah, like this one. If we give more energy, we make heating for the material. We can make one electron goes outside. We can make an electron go outside. Okay. So the number of electrons can reduce, or we can give an electron, so the number of electrons increases. Okay? So it's not fixed, the number of electrons, but the number of protons, it is fixed. You need to destroy the nucleus to get one proton out, so it makes explosion. Okay? That's so it's not our work. Okay? So from where, if we want to take one electron, from where we can take the electron? From the first shell, second shell, or the last shell? Last shell. Why? Exactly. Did you study before? That's a good guy. Okay, that's exactly that, because the last shell, we need less energy to take it out. Okay, so you start with the outside electron. These electrons, which exist in the last shell, we call them valence electrons. Valence electrons. Okay. So anybody knows what is electricity? What is electricity? How we have the light? How? Anybody? What is electricity? One by one. Go ahead. Power of electrons. Acceptable? Any other body? That's good. Anybody else? Heat. Okay. Not bad. Not bad. Anybody else? Just any idea? I accept. Electrons move. That's perfect, I think. Okay. So what is the speed of electrons? Speed of electrons. What is the speed of electricity? Speed. I turn on the light. What is the speed that it works there? What is the speed? Speed of light, right? Right? It is 3 to power 8, 10 power 8, right? But is this the speed of electrons or not? My question is that the speed of electricity or the speed of light or this one is 3 to power almost 3 multiplied 10 to power 8 meter per second. Okay? This is the speed. But is it the speed of electrons or not? Or what is the speed of electrons? 6.25 meter per second. Power 10 What is this? Boltzmann. Stop. Boltzmann constant? Maybe something like that. But it's not. So what I want to say is that the speed of electrons is very slow. It's maybe depending on the material, but it can be 1 meter per second, or 1.5, or 2 meters per second. So what happens? How we can get the electricity? Okay, I tell you. So the idea is that the electrons move with the speed 1 meter, okay, or 1 meter per second. But the effect of movement is very fast. The effect of movement, okay? It's not the electron itself, okay? But we have the electrons moving, so the effect of the vibration resulting from this one is the speed is this one, or almost this one, okay? But not the electron itself, because the speed of electron is low, okay? Should consider that, okay? Is it fine, this one? Is it okay? Okay. So in each shell, what is the number of electrons? In the first shell, how many electrons we have? 2. In the second? 8. Third, and so on. So the number is 2 n square. And n is the shell number, okay? The first one we have 2, second we have 8, and so on, okay? And what I said before, that the atom, when it is alone, the number of electrons equal the number of protons. Electrons equal protons, the number, okay? But we can add an electron or take out an electron, okay? Fine. Like, for example, O2. O2, okay? So the O2, we have one O and one O, okay? And it has one electron outside and one electron here, okay? This atom takes both of electrons like this. And this one takes both of them like this, okay? So as if we added this bond, we added one electron here and one electron here, okay? So it becomes O2. But O2 is not the atom itself. It is 2 O atoms together, okay? So in this case, we have adding one electron, we have negative ion, or we take one electron, we have positive ion, okay? Fine? Fine, okay? Okay? This is your first class in English? Yes. All? First class in English? No. 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 Okay. The students who, no. The students who studied with me programming and electronics, right? So, yeah, okay. So, is it hard for you, the English language? No. It is similar to Korean. But, yeah, it is the... You should get used to, okay? You should understand that English language is very important, okay? It's not just foreign language. No. Not at all, okay? I studied in France, the master. All the books in English, even in France. All the books are in English, okay? So it is the technical language, not just speaking language, just saying going to drink with somebody to speak the language. No. To get a job, you must know English. Good job. To get a good job, you must know English. Okay? So that's what we called it ionization. Ionization, it means adding one electron to the atom or taking one electron from the atom. Okay? Okay. As I said before, that we have three kinds of materials. Three kinds of materials. What are these? The materials are material which does not conduct, okay, in normal conditions. Normal conditions, it does not conduct. Okay? It does not conduct, and material which conducts, like the metals. Okay? The metals, they conduct. And usually they have one electron in the valence shell. Okay? So the insulators which don't conduct, like rubber or glass or wood, as you said, yeah. And conductors are like copper or aluminum, this stuff. Okay, why it is conductor? Why the copper is a conductor and the rubber is not? Why? The electron almost free. The electron in the valence shell is almost free. Okay? So it needs very small energy to leave. Okay? That's why here the electron is very attached to the nucleus. So you need huge energy to take it out. So that you can, if you have high voltage on some rubber or something like that, if you put very high voltage, it will burn. Okay? It will burn, not conduct. But this is a sign that it started, the electrons started to move, okay? But it burns because the energy is too high, okay? And we have our friends, the semiconductors. In our electronics applications, we don't want somebody to conduct very fast. We don't want that. We don't want it to be insulator. We don't want. We want some element, material, that I can make it conduct and I can make it stop conducting. I can control this material, okay? Like the semiconductors. Okay? Fine? Oh, okay. What time is it? What time is it? 30? Okay. So the semiconductors, the basic idea is that if you have a semiconductor material like this one, semiconductor, and you have a battery here, okay? You start the voltage here, increase, for example, this situation. This voltage increases until some point this semiconductor becomes conductor. Okay? Fine? So, but the problem in semiconductors alone, like silicon. Do you know silicon, right? We use it so often in the electronics, right? Or germanium, or carbon. Okay? These are semiconductors. Did you see the carbon? The usage of carbon? Did you see in any device? Anywhere? Carbon? Ah, okay, I understand. I got your point. But did you see any application of the carbon? Huh?
In the body of bike.
The body of?
Bike.
Bike. It is where?
Everywhere when I see the bike, some expensive bike made a body in carbon.
Okay, okay, I see. Yeah. But what I want, an application of the carbon in such a way it is semiconductor. Okay. Do you know the mixer? Mixer. Yeah. The mixer in which we make fruit or coffee or something like that. That one. Inside there is carbon to conduct. Sometimes you should change these carbons because they already expired. Okay, so that one, it can be the silicon. Silicon and germanium, you have silicon is used frequently in the mobile phones, all the electronics. Okay. Okay, fine. Do you know what we had before the semiconductors? Do you know? I think the first transistor, it was in the year 1962 or 50 something. So it is just recent. But before that, we had what? Do you know? The vacuums. We had some vacuums. What is in Korean? That one. So we had the vacuums before the transistors. Okay? But nowadays, the electronics, every 6 months, we double the power of electronics. That's why some time ago, the mobile phone was huge, like this, right? But nowadays, it is just very small and light. Why? Because we have improvement in the electronics industry. Okay? Okay, fine. So, you see, this is valence band and conduction band. If the electron is here, it is not conducting yet. But if it moves to the conduction band, it will conduct. Okay, makes electricity. Okay. So in insulators, the gap between valence band and conduction band is huge. You need huge energy to make the electron moves from valence band to the conduction band so it can conduct. Okay? A huge one. In semiconductor, we have a medium gap. Okay? We will study later on how can we reduce this one. Okay, by injection. Somebody said by doping or injection of something. We will see. And for the conductors, it's almost conducting. Okay, and actually in the copper, for example, in the copper, when you look at the atom, you cannot say that this electron belongs to this atom. You cannot, because they are all mixed together. Okay, it's like water of electrons. Okay, they are very ready. They are ready to conduct. Okay, maybe you just take the material and you move by your hand. This energy is enough to make the conduction. Okay. So that's okay. Okay. In this figure, which is more stable, these electrons or these electrons? Which one? This one or this one? This one or this one? One or two? Second is more stable? No. This is stable, right? This is stable, right? Because it needs less energy to leave. Okay? So take this example. We have the silicon. It has Ne equal 14, and the germanium or Ne equal 32. Which is more stable, this one or this one? Huh? Silicon. Why? Because it has how many shells? 3 shells, right? 3 shells. This one it has 4 or 5? 4? 2, 8, 6, 4, 16, 18. 2, 4. So it 2, 4, 8, 18. 4. It has 4. So this one, the valence electrons are in the 4th shell. This one is in the 3rd shell. So this one needs more energy that the electron can leave. Okay? This one needs very small energy. That's why the germanium is less stable. Any energy can make it conduct. So we don't want that. We want some stability. But maybe in some applications, we need this one. Okay? Because why? Because this one sometimes it can conduct without our control. I put the mobile phone here, and maybe there is something heat here, so it conducts. We don't want that. Okay? Yeah. So these the energy gaps. Okay. Okay. So in nature, the atom, one atom does not exist alone. Right? No atom alone. You have this one is the iron, for example, all together. Okay, all together. So they make something we call it bonds or covalent bonds. For the silicon, for example, this one is silicon, I think. Yeah. Okay. So this atom. So take an example. This atom. Okay. It has 4 electrons. 4 electrons in the valence shell, right? Right? It shares 1 electron with this atom, 1 electron with this atom, 1 electron with this, and 1 electron with this. Okay? So this atom, it has 8 electrons, so it becomes stable. So it is stabilized, okay? In this way. And this one with others, and so on, for the whole structure. Okay? This one can be represented in the bonding diagram in this way, that we have 2 electrons are shared, 2 are shared. Okay, fine. Guys behind, it's fine. Do you hear me well? No problem. Huh? Louder, okay. Tomorrow I will bring the mic so that you can. Okay. So if we have, take this example. If we have the valence band, and the conduction band, valence and conduction, and we give energy. Are you okay, guys? Guys, there. Do you want I ask you to go out? If you are not interested, you can go out. No problem. Okay? No problem at all to me. Okay? Okay. So if we have a valence band, the valence band, it has some electrons, right? And we have the conduction band. This one is the conduction band. The valence band, if we put some energy, or heat energy, some electrons will move from here to the conduction band, and become free electrons, free to conduct. Okay, free, it means does not belong to any atom alone. What happens that here the electron was there, this, and it left this place. This place we call it hole. It is positive. Okay, because some negative went out, so this part we call it positive hole. Okay. Okay. we said that electricity is what? The result of the electrons movement, right? When electrons move, they generate its kind of electricity or conductivity. Okay? So some electrons can move from here to outside, right? But other electrons can move from negative to positive, right? So we have two kinds of conductivity or current. We have two kinds. The first one, that these electrons are moving outside, and the second kind, these electrons are moving to the holes. Okay. So this this one is what we wanted to say. The electron current. Okay. So that one is the reason of this current is that the free electrons move in the conduction band. Okay. And the whole current is caused by the movement of valence electrons to the created holes. So when some electron leaves the valence band, it leaves some hole there. So that hole is positive. So some electrons in the valence band can move to this valence, that is this vacancy, which is the hole. Okay. So, okay, fine. So as I told you here, that the semiconductor alone, it does not have many free electrons to make the movement, okay? So how can we increase the conductivity? How? How? Huh? High voltage. That's true. That's true. So you can push the electrons to go out, okay? That's a solution. But if you need high voltage, your mobile phone needs high battery, right? Okay? This is not the perfect solution. The perfect solution is that I add electrons. I add electrons. Or I add holes. Okay? How to add electrons? How? Huh? High density what? So we want to dope, to add something, not silicon. Okay? Not silicon. Other material. Okay? That material, it must have some characteristics, right? What kind of characteristics? The silicon, it has how many electrons in the valence shell? How many? 4, right? So if we bring an element which has 5 electrons in the valence shell, so it makes one bond with this one, this. So we need 4 electrons, and the remaining electron will be free, right? So we added 1 electron, free electron. Or we add some material which has how many in the last shell? 3. So that it makes bond with these 3, and 1 is whole. So this one also can increase the conductivity. Is it fine? Fine. Okay there, guys? Yeah. So the elements which can be used in this case, okay, something like arsenic or antimony. This one is boron or indium, some material like this one, okay? Okay. So what we explained today, I have the watch. Okay. You know why? I asked what time is it, and I have the watch. Because I don't use the watch for my at the time. I use the mobile phone. Got used to that. But my wife asks me to wear the watch. Okay. So the atom, it has three things, right? The first thing is what? Proton, which is positive. Pros and cons. Okay. This is expression in English. With or against. And neutrons, which are neutral. Neutral means not positive, not negative. And electrons, negative. Okay. The electrons is the entity or the item which we can play with, increase, decrease, make conductivity, something like that. Okay. And semiconductors, they have two kinds of current: electron current and hole current. Okay. The electron current when we have free electron, the hole current when we have an added hole. Okay, not a free hole but added hole. Okay, we can dope the semiconductors. Okay, and we can in material means negative material when we have electron current. Okay, and P material when we have a hole, free hole. Do you know the word penta? Penta? Do you know pentagon? It means what? 5. 5. Do you know the 5, right? The Ministry of Defense, the American one? The American Ministry of Defense. It has 5 pentagon. They call it pentagon, right? This pentavalent. It means it has 5 electrons. Or what's that? 3-valent. 3 is 3. Okay. Okay. So that's what I wanted to say today. Do you have any question?